Alright, we're looking at area, and in the previous video we were approximating the area under the curve and we were using the right endpoints. But this time we're going to be using the left endpoints. So let's take a picture or look at a picture. Let me write the function up here that we're looking at. F of x is equal to negative x squared plus 6, and we're on the interval between 0 and 2. Let's draw a picture, or at least attempt to draw a picture. The reason that this is so difficult, I'm drawing on a sketch pad that's got an extremely smooth surface. We're between 0 and 2. And we're wanting to find the area under this curve. Now we're going to be using the right endpoints this time. And the right endpoints means it's going to be the right part of the triangle. And like I said, I'm going to attempt. This is not going to be to scale here, but at least you'll get the idea. We're going to be dividing this into 5 pieces just like we did in the previous one. At least that's the one we're going to work with. And then of course I wrote a program to do an n number of pieces. But if we divided this into 5 pieces, we would end up with 2/5 would be the width of this rectangle, and of course the height of the rectangle is going to end up being the f of x, or I'm sorry, f of 2/5 I minus 2/5. I just about forgot what the heck I was doing there. And the reason this time there's a minus here, let's look at this one here for example. If my eyes are going to be 1, 2, 3, 4, and 5. If I come out to the second one, okay, this is what is coming in contact with the curve. So if I come out to here, yeah, the second rectangle, if I plug 2 in for I, right, so this is 2/5 and then plus 2/5. But what's happening here is I'm going back and I'm subtracting off a 2/5. So remember, if I were equal to 1, you would be here. Okay, if I was equal 1, then we would be here at 2/5, because I would plug 1 in right here, and 1 times 2/5 is 2/5. But then if I subtract off a 2/5, then we're just back to here. See? Okay? And that's how we're going to get our left endpoints. That's how we're going to get the left endpoints. And of course, this is not divided into 5 pieces, but anyway, you get the idea right here. So you can see that when we divide this into 5 pieces, notice that this part of the rectangle here is outside that we're also including in our area. So our area is going to be greater than the actual theoretical value. Okay, the area, once we sum up all of our rectangles, it will be greater than the actual theoretical value of the area. All right. So just like we did in the previous problem, we are going to take f of 2/5 I minus 2/5. So that's going to be the height of the rectangle, and the width is 2/5, as you can see here. And we'll be summing that up from I equals 1 to 5.